Hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. My name is Miss Rosa binti Ismail. So we meet again in topic 3, inequalities and absolute values. It takes 14 hours to settle this topic 3. So we will start with 3.1, which is we call as inequalities. So there are 5 course framework to settle 3.1. At the end of the day, you as a student should be able to understand the basic concept of inequalities by using number line, and then to relate and use the properties of inequalities, and then solve linear inequalities by expressing the answer in interval or set form, solve quadratic inequalities by using either graphical or analytical method, and to solve simple rational inequalities. Let's start with the definition, which is an inequality is a relation between two expressions that are not equal. The symbols used are as follows. The first symbol is greater than, or sometimes we call this as more than, and then we have is greater than or equals to, and then we have less than, and is less than or equals to. Okay, this is a few basic concepts of inequality by using number line. So we categorize it into 3. The first one is in interval form, the second one is in equality form, and how to represent it on a number line. Okay, let's start with the first one, which is what we call as open interval, because here we have interval A to B, but A and B does not include. So how to portray it into inequality form is X greater than A, X is less than B. So X is between A and B, where A and B does not include. So how to represent it on a number line? So let's go with the method here. So we have open interval. How to represent it on number line? First, we must draw a number line, and after that, we denote where is the first value, the least value, and the greatest value, which is considered here as B. And then A does not include, so we represent it as an empty circle. B also does not include, so we represent it as empty circle, because the interval is between A and B, so we just connect between these two empty circles. So that's how you represent it on a number line for open interval A to B. How about closed interval? So closed interval, right? So A to B, where A and B are included, and how we portray it into an inequality form. So A to B, X is greater and equals to A, and less than and equals to B. Okay, let's represent it on number line. First, we draw a number line, the least value, the highest value. Okay, since A include, so we'll draw an empty circle. B include, also an empty circle. So connect between these two dots. Alright, and then we have half open interval. Half open interval, that's mean either the least or the highest value include, either one. Okay, let's take a look at the first half open interval, where A to B, A include but not B. Okay, so how to portray into inequality form? A is greater than and equals to A, where A include, and less than B, where B does not include. Let's draw it. So we will have again A, the least value, B, the largest value, the highest value, A include. Since A include, that means we will have connect between these two dots. Alright? Okay, so let's try with half open interval. What do you think? Okay, first come up with the least value and the highest value. A does not include for this half open interval, that means it will be empty circle, yes. And then B include, so it will be dense circle. Alright, so connect between these two dots. So we finish with the first basic concept. Let's go to the next one. Next thing, we have basic concept of inequality by using number line. We have infinite interval. infinite interval, that's mean it starts from A and it goes to infinity. So how to portray into interval form? We start with A and then to infinity. And how to portray into inequality form? We have x greater than A. Alright, so how to portray into representations on a number line? Okay, first draw the number line because we have only a point here. Okay, sorry. So we consider this is as A. Okay, here is A does not include, right? So we just draw an empty circle on A. Since it's greater than, so it will go straight to the right to infinity. Alright, and then we have infinite interval. Infinite interval, the second infinite interval where A include. So we will have A again, the only point there. Since A include, so we will have a dan circle. Since it's greater than, so it will go straight to the right. Okay, and then we have infinite interval. The next infinite interval is negative infinity to B. Okay, the inequality form here is x less than B. Okay, x less than B. So we will have a number line. The only point there is B, but B does not include. Since it's less than or negative infinity to B, that means B is the highest value in this interval. Okay, so since it's from negative infinity, so it will go straight to the left. Alright, so let's try next infinite interval. So we have B here. Since it's include, it will be dan circle. So less than n equals to. Less than n equals to. So that means it goes straight to the left. How about infinite interval? The last one, negative infinity to infinity, which is actually a real numbers. All numbers include. So it will be no specific numbers. So it will be just like that. Okay, this is represent real number. Okay, so let's take a look at a few notes. Okay, so this is a notes that we discussed just now. A to B represent an open interval since A does not include, B does not include. Okay, and then we have A to B represent a closed interval which both include. While if either one does not include, either the least value or the greatest value does not include, so it represents as half closed interval. Okay, and then we have empty circle, indicate the end point is not in the interval, we discussed already. Okay, and we have a dan circle, indicates the end point is in the interval, which is include in the interval. Alright, so till then, we meet the next page with example 1.